first part of this presentation is about just the Globalstar system, how it works, who we are, that sort of thing. And those will be in the slides that will be distributed. So I'll just quickly go through those, and we can get on to the other parts of it. So let's see how we
can just cue me and I'll go to the next slide.
Okay.
It's a PDF, so.
Okay, you can go to the next slide. Okay, so Globalstar, we were founded here. We were a partnership of Qualcomm and L'Oreal, and then later that got bought by Thermo, and the headquarters was moved to Covington, Louisiana. We still have operations here in Milpitas and California, and actually all over the world, so you'll be able to see that in an upcoming slide. Let's see, we've got the global satellite network. Okay, this is for a different purpose. Okay, next slide. This is our next generation of satellites. Our first generation of satellites, we had a problem with the forward link, which is going from the ground to the remote modem. And what happened was that due to the uncharted, uncharacterized space environment in the orbital segment that we were at, the radiation environment was a lot tougher on our S-band electronics than we had expected. So with our new satellites, we've separated the S-band into two antennas there that are sort of 3D cones there. One and the other is sort of behind it, you can't see it. And that covers our central beams and our outer beams. And let's see, we operate as a bent pipe. So we, from the gateway, we send C-band up to the satellite, which does a frequency conversion to S-band into the different beams and sends that down to Earth. And then the terminals themselves will transmit in L-band up. That's received by the satellite, frequency converted to a different C-band band, and then that gets sent down to the Earth gateway station. So let's see. I think that's it there. We're operating at 14 kilometers, and we're inclined at 52 degrees. Next slide. This was just meant to show that our delay times, the latencies, are comparable to what you get on terrestrial systems, because it's so low Earth orbit. And since we don't have any processing on board the satellites, it's just a bent pipe. We don't have any delay due to the 1995 vintage processors that would be in the Iridium and Globalstar constellations that are up there. Of course, this satellite here, these satellites are much newer than that, but still, we don't have any of the delays up there. And also, since we're just doing the bent pipe, we're going directly back down to Earth, and so we're not doing the much longer time of flight paths between different satellites to get down to to get to a working satellite and then be able to downlink to Phoenix. Okay, next slide. The bent pipe, this is just showing that with our simplex and duplex terminals, it's a duplex handset there, and the spot is a simplex emergency transponder. We're just messaging transponder tracking. We transmit in L-band, and we receive in S-band. And the simplex devices are transmit-only devices, so they don't have the S-band return. Okay. And then to and from the gateways, we use C-band. We're using left-hand circular polarization for our terminal communications for both the S and the L-band. Okay, next slide. We've launched our next generation of satellites, and that was successful. We got the 4 successful launches. Got all the satellites up there and working, 15-year design life. And of course, our original satellites were, I think, a 7-year design life, and they went from 1999 to 2015. So at any rate, we would expect them to last longer, but that's the design life. Okay, next slide.
How many went up over those 4 launches? Yeah.
It was for 24. 24.
But it's I thought it was a 36-node constellation.
Well, we're authorized to fly 48 for the constellation, for the the active constellation. Right now, we're using the 24 of the new birds and 8 of the the first generation. So we have I think I don't know if that talked about it here. One of them, the slides talks about the Walker constellation, and we've got 8 planes with 3 satellites each. So in terms of our operations and our ground stations, the ground stations are the blue, green, and green dots. Okay, the red dots there are deactive or inactive ground stations. And so you can see all of the active gateways, and the green ones are ones that are operated by partners of ours, whereas the blue ones are all Globalstar owned gateways. We have a number of TT&C sites. We have 7 of those, and those are denoted by the T in the middle there. And we've got offices at the yellow dots there. So
What's TT&C?
Telemetry and control. Okay. Yeah. And something else.
Timing and control.
Thank you. Yeah, it's and let's see, and these have a number of these have the simplex appliques, and all of them, of course, have the duplex capability. Simplex is a transmit only from our terminal, and so it does not use or require a two-way handshake with the gateway. And so since it is doesn't require it, so that means that when it transmits, it's transmitting just in broadcast mode, and then that frequency is picked up by any of the satellites that are in view, and they send down to the gateways that they're tasked with at that time, or the gateways that are tasked with tracking those particular satellites. And so when you transmit a simplex message, it is actually relayed to our control centers back in California and Louisiana. It's relayed from every gateway that picked up that message. So you can send a single message, like in North America, you'll send a single message, and you may get 5 copies of that message coming in to our central office. And it deduplicates in the central office. Each gateway deduplicates. The gateway says, oh wait, I already received a copy of this, a successful copy of this message, met the CRC, and so I'm not going to forward this one. Right. And so they do that, or they receive one and say, oops, this is a bad message, and it doesn't forward it. So there's the triage that's done out at the individual gateways, and then our office goes and deduplicates. And then when we get a contiguous package of all of the packets that were in that message, then we forward that to the customer. So when Kyle's talking about his 36-byte messages, which are 4 9-byte packets, once we get packets 1 through 4 successfully, and we may get packet 1 and 4, and then later we get 2 and 3, from a different gateway. But when we get all of those, then we send them to the customer. So there are some considerations there that we would talk with you about when you're implementing, which is, like with the TSAT, they had structured it for sending only 2-packet messages, or they were sending multi-packet messages. Well, since maybe the first or the second packet of a message wasn't getting to us successfully, we weren't forwarding any of that to them. And so I talked with them about, how about sending your messages as all, even though it's a 2-packet, message of information, send it as 2 single-packet messages, because that way, as soon as we get one, we'll be sending you those, and then, they know what data is supposed to be coming in, and they've got some information in the payloads that they can associate that, and then they can either, construct their data from, a full data set or from a sparse data set. They can, it gives them a little bit more to go on. If that's amenable, there's some data that's amenable to that, and others that you really need it to all be together. So
if I could ask, what happens if your transmitter is over the Pacific Ocean, so it's far away from land, so it will transmit a message to whichever bird is flying over, and does the satellite then store it until it sees the ground station?
No.
Is there latency, or how does that work?
no, it's just a bent pipe. Now the terminals don't transmit to a satellite. I mean, they're just transmitting. Okay, they're not doing to a particular.
Right. It's probabilistic. So
Yeah, so they're just transmitting, and so whichever satellites will pick that up, will then relay that to the ground station that they're communicating with. So like when we're over the Pacific, or when you were over the Pacific, you can see that Kyle had a lot of dots there, and even in the South Pacific. And what was happening was because in the Earth orbit, it's transmitting. That will get picked up by a satellite that may be communicating with Venezuela. Okay. And so it will be more sparse there because you're not really near. Because the gateways, those antennas are, directional antennas, and they slew back and forth, and they're optimized for whatever their service area is. But if there's a low angle, RF that comes in from some, it's taking whatever comes in on that L-band frequency, up converting and sending it down by C-band. So if it gets picked up by a satellite, it'll get brought, carried on down. Okay. That's for simplex. For duplex, even though it could see the same, the RF signal can get to the same place, a duplex honors the national boundaries.
Oh, I see.
Okay.
Oh, so you have to be within the contiguous.
You have to be within the service area of the gateway
to be able to transmit to it. Otherwise, got it. Okay.
Otherwise, it says, "Oh, you're not in my service area.
Can't.
You should be on a different gateway."
All right, gotcha.
Okay.
All right.
So let's go to the next slide here. So the space segment. These are our 24 satellites, and you can see that they're covering the Earth there. And as I said, if you have something over the South Pacific, now if it gets picked up by that one right smack dab in the middle of that's not going to be communicating with anything in South America, but it may be picked up by one of the birds that's closer to South America. We've seen that. We saw that during the TSAT re-entry, where the messages on the re-entry were being picked up by Venezuela and then Europe, even though it was coming down sort of over the the mid-Atlantic. And since it's a forward-facing patch, then it was sending that. Let's see. So our Walker constellation of the 24 LEO satellites with the fill-ins with the 8 other satellites that I talked about. That's 8 orbital planes, 3 satellites each, 52 degrees inclination, and 114-minute orbit period. So when you're up in space and your bird is flying at a particular orbit and inclination, if you're basically inclined like we are, well, some of your people ask about Doppler. Some of that Doppler is going to be a bit less than if you were on the ground, and some of it is just going to be way out of the ballpark. And so, that's not it. Those don't get transmitted. So there's no issue with that, whether it's a duplex or simplex. It'll either get picked up and or it won't be. And it's not like, wow, something is corrupted or.
I didn't realize, but the operating altitude is quite a bit higher than Iridium. I think Iridium is
Yeah.
680, 700. So you guys are almost twice as high.
Yes.
Okay.
Yeah.
And obviously your orbital period is significantly less as well.
Okay, next slide. A ground segment, anything of interest here. We have our Space Operations Center, the SOC, the Gateway Operations Control, the Tracking, Telemetry, and Command, and those are all work together. We have distributed control centers here in Milpitas and in California, Louisiana, and France. And so that we are, as immune as we can be from, try to distribute so that if we have an earthquake or they have a hurricane or whatever, that we're always able to, keep operations going.
So if I can ask questions, just for clarity. So if one had a requirement that you needed to uplink a command to the nanosatellite once per orbit, you couldn't do it. Is that correct?
No. Well, it depends how you do it. I mean, you could do it through SMS, because SMS with the duplex system, the SMS it's text messaging, and so it uses the duplex phone, duplex radio.
Okay, so SMS is two-way then. Maybe
Yes.
Maybe I didn't understand the nomenclature.
Yeah, the phone registers with the gateway,
Okay.
Which is a two-way process.
Okay.
To set up the validity of the subscription,
Okay.
Get it registered, and then when a message comes in, when you send a text message to it, it gets received by our server,
Right.
and our server checks its database, its location register to see, is this modem active anywhere? It says, oh yeah, it's active over in France, and so it'll forward the text message over there to tell it to uplink, and then it will uplink and send it right to the modem. Now, if it sends it and the modem has moved out of the surface area, then the gateway will say, unsuccessful delivery, and so it'll just keep it in the queue.
Right.
Okay.
Right. So if you happen to have if your nanosatellite is in orbit that is away from the the service area, like over the Pacific, et cetera, on the backside,
Mm-hmm.
then that message will stay into the queue until the orbit precesses and is finally over a service area.
Over a service area,
Right.
right, and it registers.
Correct.
So,
But therefore, I mean, just again for clarity,
yeah,
you can't guarantee an uplinked command message once per orbit.
well, I think with proper management of that, you could. I mean, if you know your orbit, okay, and you know your GPS, when you're going to be over Russia or
Right.
France or South America, you know those things. You have your modem get up. You can have your modem make sure that it gets service then. You don't need to try to get service, and you don't want to try to get service over the South Pacific because it's a waste of resources. But if you do that, and then on the ground, you also have the ephemeris, so you know where these are. And so there, you bypass this, it was undeliverable.
Right.
We also have the ability for integrators to be able to send your text messages. You could send them, you can send them from your phone. So yes, Kyle could command a spacecraft from his phone.
Right.
But more valuable, I think, is the fact that you can send it from a server. Okay, so we send it over HTTP, over Telnet. And so we telnet to the, you would telnet into our messaging server, and then we would deliver you a delivery confirmation so that you would know, it got there or it didn't. So that would help you, because if you said, wait, it should have been over Russia, and so I sent the message, it didn't get there. Well, then that one will go in the queue. But you can say, you know what, I'm going to send a new one once it gets over, once it starts getting over South America or North America, because I know I got other coverage there. And then you send a new message in. The system will that whenever it gets a new message, it attempts to deliver that right away. Okay, and if it's unsuccessful, then it goes into the queue. And then when it is successful, it delivers that, and any others that are queued up, follow suit.
So that effectively resets
So-
the queue.
So that will clear out the queue.
Okay.
So that means that, so if you needed to get to it once in orbit and, you missed the South America pass, or, you can pick it up, you've got the knowledge there that you typically, at least a little bit into the mission life, you have a pretty good idea of where your bird's going to be.
Okay.
And then you can use that so that then your SMS delivery time is not on the order of 4 hours to 14 hours, which is clearly a queued time. And that's all the SMS delivery queuing and stuff is all on the web.
Okay.
But
But you do need the longer board in order to do that.
you need the longer board in order to
I
do
want to be
that.
very clear.
That's our
You-
current, that's our Gen 1
the
board.
duplex.
Yeah, our current duplex.
Okay.
Our new board is going to be much smaller than that.
Okay.
Okay,
What does that come out?
um,
And it will fit a PC-104 mechanical form factor. If you're 10 by 10 centimeters, a little bit less.
I would expect that we're going to be like, trying to make that as small as possible. I don't think, my hunch is no, it's not going to be a PC-104 factor. I mean, that would be the simple,
Okay.
off the cuff answer, because we're going to try to make that modem board
It's smaller.
as small as possible,
Gotcha, right.
so that if someone wants to make an encrypted phone, they can take that and stick it with all their NSA approved encrypted, and then it goes, PC-104 is like, oh, well, then we have the PC-104, we've got this, we've got 5 different kinds.
No, makes sense. Make
Yeah.
it small as you want, so that you can custom mount it onto your.
Yeah, basically, yeah, daughter board it onto, whatever you need to.
Okay.
But yeah, it'll be much smaller.
Okay.
So then my bad, I didn't realize that. Something that when we had talked with NSL,
Yeah.
they were communicating is if we tried to send more things into the queue, they'd sit behind the one that
Oh.
was waiting. So we had always, every time on Shark.
Well,
because they-
yes and no. I mean, if it gets delivered immediately, it gets
Right.
there right away. If not, then it'll go into the queue.
What we had thought was if we had one in the queue, so we were really
Yeah.
trying to never have more than like 1 or 2 in
Yeah.
the queue
Right.
at a time. If we sent another one, it would just be third in line.
Right.
And you were totally beholden to whatever the timeout was for a retransmit from the first in line.
Yeah,
flow.
no, it's not that
Okay.
once something's in the queue, a new one comes in, that gets queued. No, I mean,
Okay. Oh.
yeah. Even
That's
if it did,
great to
even if
know.
it did, we would have said, well, this is live, let's try to get the first
That-
one out,
and-
but I mean, it doesn't. It tries
And
to
that's
get
perfect
that
to know
newest.
because that'll totally change how we try Shark when we bring the duplex online.
Yeah, it's essential to know because it tells you want to timestamp your SMSs that are getting to your craft also, so that when you get them, and they may not be in order,
Right.
that to ignore, if the message you're getting is X, you need to, you have the risk that, you've got this, you're telling it to turn itself off or, do some diversion. And this is like 2 days old, oops,
Yeah.
I'm not going to act on that command. So it tells you a couple of those things, but also it brings you back to, oh, but how can I get around this huge delay in the first place? Oh, I've got the tools at my day, and I've got the staff that can do this. So, let's get this
Okay.
put into play. And you have the phone. You can always, and email, send me an email or, call or, so we can work out any misunderstandings you might have.
And then Joe, real quick, with the ground station map that you showed, you mentioned that some sites are simplex only. Are there some that are SMS only, or all sites capable of SMS data calls?
Yeah, SMS and duplex go hand in hand.
Okay.
That whole system is all together.
Okay, so if a
Simplex
site
is
facilitates,
different.
got it.
Yeah.
Perfect. Okay.
Okay, next slide. Okay, our knock. Go to does all the things a knock would do. our markets, what this was developed for was emergency messaging and emergency phones, handling when networks go down, and handling, out-of-band communications. So if your, LAN communications are compromised or overloaded, or you have a backup system. So we can address all those things, but it's not really the topic of this conference here. Next slide. So our product portfolio, the duplex is the 1700 phone and the 1720. We also have a 1620. Now, those two are both data and voice capable and SMS capable. Okay, so that's what that is. The SAT-5 just takes a 1720 board, the voice data modem or data voice modem, and puts it in there along with a SIP server and some other goodies, so that it can serve as a hotspot for your smartphone, so that your smartphone, all your contacts and your apps, you can communicate through the satellite system. The next was the spot messaging, which is for emergency communications. The orange thing, you press the button if you need to, and the helicopters come in and save you. Or you can use it just for sending messages to your family. A couple of options there, and we keep enhancing that product line.
So more than just what we used to call a pager, I guess, right? As a pager was limited to, I can't remember how many bytes, but
yeah, the pager was to receive messages from the network. Well, there was
Right.
two-way pagers too.
Two-way.
Yeah. Okay. So what we do here, since our simplex messages are 9 bytes, and the reason for that is so that we have the highest success rate of those.
Sure.
Of those. Okay. Because it's not handshake, it's CRC, but it's not. We don't have retransmit capabilities. Retransmit is done by the unit. So at any rate, since it's such a small payload, what we'll do is you'll send either a help message, an SOS message, or a custom message. And what those are ones that you've got on the web beforehand. So, custom message 1 means, send to these folks this particular message. If you're hiking, it might be, put some food at the next drop spot. And people can look at what your tracking was and know, oh, okay, Johnny means, this place here, or the help might, so that's what that is. Now, we do have other ones that have Bluetoothed into them, so that from your phone, you can actually send a custom message into a text message where you actually type a particular message, and then it sends that over simplex. But the unit itself right now, current simplex, doesn't have a keyboard or anything like that. I mean, it's just you send those single button things. It's for simplicity, reliability. The Trace is a beautiful little unit, and that's just about this big. Runs on 4 AA's for about 4 months. If you got it in your car, turns itself on, tracks you whenever you're moving. Every 5 minutes.
it doesn't have a GPS on board, or does it?
It has a GPS on
Okay.
board. Yeah, so you'll get alerted when an asset moves and where it is, and then it turns itself off once you've stopped.
Do you know which GPS, by the way? Is it a U-Blocks or something similar?
I don't know which
Which
GPS we're using on,
Okay.
chip we're using on which of those units, but they're all embedded in the
Right.
unit itself. But they're
The COCOM limits be removed?
Mr. Kyle's reading my feeble mind.
yeah, no, we've worked on that with. We can talk about that.
Okay, that'd be
Because
awesome.
I know you're working on
Because
that.
U-Blocks won't do it.
Yeah.
We found another vendor that will for a
Mhm.
mere $30 if you.
$30, that's it?
It's ridiculous. I'm suspicious. Yes, it's
That was one of those shut up and take my money, right?
It's a Taiwanese company that apparently has a good reputation, but
Yeah.
that's works.
Okay.
for
And
me.
route your data through us.
But I don't know if it'll log.
Okay.
But for surprisingly a little bit of money, they'll
Yeah.
remove the COCOM limit. So
Okay. Oh, I'll have to talk about that. And the STX3 is that's the next generation of the STX2. And finally, we have the STX2 and STX3 in our industrial trackers, industrial asset controls. And those have not only tracking or vibration sensors, but also, dry contact inputs and serial inputs so that you can send all sorts of data, over those. No.
Actually working with the USGS bird tracking device
Mhm.
using STX3.
Okay.
So
Okay.
we're shortly going to have lots and lots of really small STX-based devices winging their way around. So we'll have lots of data.
Okay. So yeah,
So the,
as you'll see in a few slides, definitely get in contact with me so that we can, review that, make sure it's compliant. And,
which sounds like that's the next generation moose collar or elephant earring, right?
yeah, they're already being used for wildlife collars all around the world, being used in the middle of Africa, with great success, which is quite an astounding accomplishment because, these hairy beasts, will lie down on their sides and they're, obscured and the antenna. So it's,
Well, plus GPS. So, previously we used the old previous generation Argos in order to try to we experiment with that kind of stuff to pick our floating suborbital debris from the ocean.
Yeah. Yeah, no, it's absolutely fabulous, and people have, done unauthorized tests of, using this on, transcontinental flights and things. Where, there you're in a Faraday cage, and it's maybe transmitting through one of the windows, and you get this, beautiful track exactly of where it goes. You put it in a FedEx package, and you can see that, where it comes out of the truck, and even when it's in the truck, because I got skylight, and it's in boxes, it's covered by all sorts of other things. So it's it's a pretty. The Simplex is an astoundingly robust and reliable, successful messaging. So that's something.
Again,
Next slide.
Just because I'm a little bit thick.
Yeah.
But if you want to do an uplink command to your satellite, it is duplex, and it's going to be right now it's just the version of the 1720 board, which you are in the process of shrinking. Is that?
That's right. We're coming out. That will be part of our next gen ground system. You'll read about the Gen 2 Globalstar ground system, which is all packet based. It's 3GPP, and that will be. We're testing that right now, a few miles from here and all over the world.
What is that coming out?
We're
TBD.
TBD. Yeah. We're in pretty active live testing with that right now.
Great.
Okay. So, and we are definitely we are also working on, and we'll be coming out with a two-way simplex. Okay, I've talked to you about the power and the robustness of the simplex the transmit only. But we also are developing, testing the ability to have simplex on the forward links so that we can send a broadcast, like a paging message out to a unit, so that you can have this two-way communication that's uncoupled. So you don't have to wait until you have a two-way communication with a particular ground station. If we know the region that it's in, you can send through that particular gateway. It goes through the satellites and then goes down and gets picked up by that. So you'll have.
You don't have an ACK that you got the message necessarily.
Right now on simplex, you do not. There is no ACK that's
You have
there.
two simplex links.
But if you have two simplex links, then you get your ACK. Now, it's not going. It's going to be a loosely coupled communication, but I would say look at that. Look at the advantages that brings you. I mean, certainly it's not good for transfer of image data or sensor data, but in terms of getting ACKs to what you sent or whatever, yeah, I mean, there's a lot of value there. So there's a lot that can be gained from that, and it frees up a lot of the restrictions that you have with the duplex. So every tool for the right purpose.
Right.
There'll be a purpose for that.
Yeah.
So, okay, next slide.
When will that be available?
What?
When will that be available?
I can't say.
Okay, fair enough.
We're working on that, and
But on that one, what would the limit of your string be that you could uplink to your satellite? So it would be 8 bits or?
No, it's going to be far more than eight.
I mean,
Eight-
bytes,
eight bytes.
or 8 byte segments that you strung together.
I'm not sure whether we're going to be going over nine bytes
Okay.
per packet or not.
Gotcha. All right.
On the simplex transmit, we send them in 9-byte packets, but we can send up to 16 of those to give you 144 bytes per message. But for a satellite implementation,
Right.
I wouldn't advise sending a whole string of 16. I would send them in smaller chunks. Okay. Globalstar in space had been used at least since 2005 on with by the Russians from ISS. There were some earlier experiments that we were surprised to learn about, which were done from Mir.
Oh,
And so yes, we got.
did you guys go through the FCC for that?
We didn't know about it. The FCC gave us a call and said, "What are you doing?" And we're like, "What?" So, anyway, and then from 2014 on, there have been a lot of CubeSat missions using simplex and duplex, but duplex has been used up there for a long time.
Do you have a number? Do you know how many?
No, I don't have a number. I was just sort of I didn't have enough time to be putting this together. I was just adding this actually over the weekend and yesterday, so just putting in some more notes about things. So as I realized, well, wait, they probably want more than just a Globalstar overview, but something specific to space. So okay, so the forecast is going to be simplex, duplex, and then what we call the half duplex, which is the two-way simplex. Okay.
Okay. Boy,
But they come up with these names.
half duplex.
Yeah. Okay. And there's going to be, I think the population of 1 to 3 use CubeSats is going to be large, and then 6U and larger are probably going to be smaller. But there's going to be a lot of these things. So next slide. Okay. And I was talking about the system design. There's a lot of things that we had to deal with. Frequencies, the handoffs, signal timing, our power levels. And we had to do that in conjunction with protecting radio astronomy and honoring national borders so that, someone in India and Pakistan were very concerned about one another. They didn't want, people going into, the first uses of satellite phones were some Iridium phones in Africa by, guys to go and slaughter a bunch of, villages.
Really?
So,
right?
Yeah.
Wow.
Yeah. Anyway, so I mean that was a bad thing, But at any rate, especially like India, Pakistan, or places where there are border, concerns, they said, well, wait, you got to honor the boundary because if we have a gateway if they have a gateway in Pakistan, we don't want people coming into India using their satellite phones to which are actually going through Pakistan, and
Right.
they don't have a legal intercept agreement with Pakistan on Pakistan
Right.
territory. So there's a lot of reasons why national borders were important. It was extremely important to other third world countries because it's a major source of their revenue is telecom revenue.
So how does Iridium get around that? They violate that right and left then?
Yeah.
Okay.
Yeah.
Because there were.
It's a different issue. That was one of the reasons why Iridium had a hard time with the telecoms with getting into particular. There wasn't the honoring of national boundaries. They would know, but still there's the issue of legal intercept right there. But the real key for especially the third world countries was the fact that Iridium with the bypass, they call it telecom bypass, the satellite phone would go up and it would get brought down in Phoenix. How would they be guaranteed of this telecom revenue, which was a major source of revenue for their country? That was a huge issue for them. It was a huge issue you would expect for Russia, because, Russia, China don't want, communications going out of where they can intercept or look at anything.
Control.
They can't control. They can't even see it. So yes, it took many, many years. Globalstar was into Russia, I think, well before Iridium because of that issue. So at any rate, so we have these compliance, and we also had the requirement to be able to roam between gateways and service areas. You have a global phone, you want to be able to use it, not have to get a subscription each place, and have various services that were either initiated by the phone or people would call in, to the modem. So next slide. So we got all of this stuff optimized for the ground level usage. There wasn't satellite usage envisioned at the time, as same as Iridium, and so we've got dynamic management of the access traffic channels. So when you go to a different country that has different frequency allocations, it honors those, and we have all of that. That also is what we do with space. We make sure that you're only in certain traffic channels, and so we have all of that coordinated. We have dynamic power management. So no matter where you are, whether you're in an open desert or you're in a very treed area, the system ramps the power level up and down to maintain a particular frame error rate that's out there. It's a 1% frame error rate that it's going to get. If you're getting more accurate than that, tells it reduce your power. So now that's helpful because we have a huge dynamic range there. We can go from 9 dBm up to 26 dBm, on our transmit, which means that when we loft these into Earth orbit now, when you're up in Earth orbit, say, well, oh geez, what's happening with this? Because the power level is way stronger, than it would be down on Earth. You don't have trees or buildings, and it's a lot closer to the satellites. But the thing is that the system power controls that to a low level, so that if there are other satellite, whatever assets, whatever is in that part of space, the signal coming from the CubeSat that's getting up there going to the satellite is the same strength as if that was on the ground. Because on the ground, it's going to put it to a higher level so that by the time it gets to the satellite, the Globalstar constellation, it's at a particular level. So, so we've got all of that dynamic power control. That being said, with satellite and high altitude terminals, the velocity RF emissions have different characteristics than they do on the ground. And so Globalstar approval with the ground systems or birds or asset controllers or whatever, and also with the satellites, Globalstar has to approve those implementations to make sure that they're compliant with our system requirements and also the regulatory requirements. Now, for ground systems, if you're going to be selling it in a particular region of the world, we make sure that that you show us that it's got regulatory approval for wherever it's going. So that you're not operating illegal transmitters, which then gets us into trouble with the Koreans or with the or the Russians or whatever, right? So, but in space, what we need to do is we need to look at each of those things on a case by case, because your satellites are different. Where you're putting those antennas is different. Every mission is different at this point. You're not putting them out like popcorn. They're all unique missions. Your attenuation, your shielding, how your antenna patterns are, things are different. So we have to take a look at that and just make sure that everything is copacetic. We have a very good relationship with the radio astronomy crew. They operate the hydroxyl reception readings between 1610 and 1613.8. And so we need to make sure that the emissions are low enough that there's nothing going into the radio astronomy satellites. That's why orientation of the satellite antenna is important. We look at that. Do you make sure that you're not transmitting when your antenna is pointing to Earth? What's the power level?
Ours does.
And that's something that you need to, that's essential that you look at. And I can talk to you about that later, but there are research groups, huge research efforts that are looking specifically at the interference of iridium into their radio astronomy. And the reason I'm saying that is because with iridium, they're using the L-band for downlink from the satellites, okay? The same as distant stars, okay? Globalstar's transmissions in L-band are all from the ground up. So typically we're hitting the back of the big dish, the radio astronomy, right? Unless you're on a hill nearby. But in space, we need to make sure that all of that's still being complied with. But anyway, that's why we're meticulous about looking at this, because we know that there are huge efforts in Europe, for example, that are looking at the L-band pollution. And if we have some satellites up there using Globalstar that are, transmitting down into there, we're going to get found. I mean, there's someone there that's going to see that, and we just need to make sure that all of that is addressed and taken care of.
But all that's coordinated in the ITU, isn't it? I mean, I thought all astronomer astrophysics requests were coordinated through that international body.
Well, that's why the allocation, ITU has allocated the various frequency bands, okay, and has gotten that agreement through the WARC conference, the World Radio Conference, with all of the countries, which says that radio astronomy is primary for 1610 to 1613.8 when they're doing their, the data collection. That's why Iridium's downlink from the satellites is a secondary allocation, but their uplink, the uplink in the L-band from Globalstar and Iridium is primary. Okay, so if we've got someone who's interfering with that, we can, the FCC will shut them down. And this is worldwide. So there's that worldwide agreement as to what the allocations are. But it's up to but the operator or the transmitter is what has to, not interfere. The ITU can't go and, control devices.
Okay, we need to press on.
Okay.
Yeah.
Okay. So international coordination is mandatory. The FCC frequency authorization has to be first to be obtained, and then they'll coordinate with the ITU. Okay, next slide. So we make sure everything is compliant here. And the FCC compliance is required for all entities. If you look at 7.23 of the Red Book and NTIA, you'll see that when a government agency is using a commercial service, they have to abide by whatever that commercial license is. And you're using Globalstar, so you have to abide, make sure that you're within our things. You don't get a separate authorization for use of the Globalstar band. And again, that's globally coordinated. So then we just make sure that the things are satisfied. And okay, next slide. So this is where I say that the FCC blanket licenses only apply, as we've said before. The ITU frequency allocations also were only for Earth to space and space to Earth. So the pathway is to obtain the FCC authorization, and then when you do that, once that's done and they've given you a temporary authorization or whatever for various, then the FCC, they're the designated coordinator with the ITU. It's the FCC and the State Department. Usually the FCC takes care of all of that, but the State Department can do it through the UN also. Okay, next slide. License application, you'd request your FCC experimental license. There's two different forms depending on what you're trying to get. You have to coordinate that with us so that we know what you're submitting, so that, because there's things in there that ask for, frequency accuracy or, particular frequency bands, and it's best to put the right information in, because if you put the wrong information in, someone is then going to object to your application, which then makes it take a lot longer. And it creates a lot of lawyer issues too. Then give us the FCC file number and whatever attachments you threw in there. And then what we'll do is we'll file a companion application. Say, okay, we're filing this application in support. We'll actually pull up that file and we'll say we're copying this one, right, and we change a couple of the content and say this is the Globalstar application is to support the research that's being done by this mission. And so we show our support for it, and we apply for our ability to service a space-based asset. You have to apply for the license to be able to transmit from space. We have to have a companion license to be able to provide service to that. And I'll do that. That typically is very quick. And then I'll send you, here's our file number. You log in, get to the file number, and you pay the $65 fee, and then everything is off and running.
So how does that work though? Because when we took U2U through the FCC, they just threw us out because we were government.
Yeah.
Right.
So let's go to the next slide here. Oh, so you have questions? Okay. I have a write-up basically on the NTIA and where I went through 7.23. So take a look at that, and I think to make things go easier through the NTIA, it would be best to refer to that. Here's 7.23. It says if I'm using, if I as a government agency am using a commercial service, I need to make sure I'm consistent with their blanket license, and I need to get FCC approval. Part of that is not FCC approval. You need to show that you're FCC compliant. Okay, that you're compliant with the FCC, because that's part and parcel of our blanket license, and also our ITU agreement. So you have to show compliance. Now, commercial users have to show an FCC approval.
Mm-hmm.
Okay, but you don't require an FCC approval. Fine, but you have to show the FCC compliance, and then you ask for the FCC to give you the authorization, because if the NTIA gave you authorization, then then that pathway would be either the NTIA says to the FCC, hey, can you coordinate this with the ITU?
Mm-hmm.
Or it would say, oh, well, I guess I'll go talk to the State Department and see if they can talk to the ITU about this. And so, one way or the other. But I mean, you have to show that you're FCC compliant, unless you had your own, unless the agency had its own, allocation. In which case, if it had its own allocation, it would still have to get coordinated with the ITU, because unless it's being used just over the U.S. But there's no such thing.
Right.
So the takeaway for me is, in addition to doing your ODAR, which you've got to do,
Yes.
and then you got to work with Bill Notley in our case,
Right.
to go through your coordination there. You need to do a coordination with the constellation.
I know.
Always. So
Yeah, so
that's
there's
been our experience as
3
well.
steps. Okay.
I'm
Yeah.
sorry.
So we file for our NTIA, we get that file number. Once that's advanced well enough, then we hand that file number over to, in our case, Iridium. They file with the FCC, and then eventually we get all the ducks in a row.
Yeah, and I'm sorry, I had.
So that's consistent with our recent
Okay.
experience.
Yeah, I've got that written down here. When you submit but when you put together your FCC application, you would include. Go back a couple of slides. Sorry, can you go back a couple of slides on this?
Tell me when to stop.
Okay, go forward to where it says experimental license. Okay. One more. There it is. Okay, I'm sorry, it was in the fine print there. So when you submit it, you'd file it, and you have to fill out the form, right? But after you fill out the form, attach the Globalstar certificate or the letter saying, okay, we are compliant with Globalstar. Bingo, just attach that. That goes in there. And then all the things that you're going to need to submit to the ITU, your ODAR, your space cap, you submit that so that those are just attachments to your license application. And then and also put in document. I mean, just have a little write-up, I would say, unless it may be that these things are talked about in your ODAR. But if not, just have a separate document that says, okay, here's how we do the emergency shutdown if we have to. Okay. Here's how we protect radio astronomy. Here's how we make sure we have the antenna pointed in the right way and when we turn it on and off. And here's how we do attitude control. So if those aren't talked about somewhere, then just have separate documents and just address those specific issues, because those are key rubbing points for them. And then the FCC, it's easy for them to say, oh, okay, I can see everything is, sort of lined up here. Then I can go ahead and make sure that this, then they'll either submit that to the, notify the ITU, or they'll say, okay, now you go and notify the ITU, but that's what they need, because there's some FCC notes out there, also, which says that didn't used to be part of what they were looking at, but for space things now, they are. They want to make sure that the ITU documents are in place, because if they had approved an experimental license, and like the ODAR wasn't done, and the, cost recovery letter wasn't, it's like, well, shoot, then when they go to the ITU, they look like bozos, it's like, well, wait, what do you want us to coordinate? We don't even have the right information on this. So they want to make sure all that stuff is in, so that coordination with the ITU is as efficient and clean as possible, just the same as I'm saying.
Yeah.
You want your submission to the FCC to be squeaky clean and just, there's no issues other than curiosity questions. Okay.
Thank you for that.
I have one question online unless you want to move on.
Oh, no, go ahead. Read it out if you can.
So from Mike Miller, is there a history of Fed/NTIA missions filing a companion application to FCC?
Is there a history?
Is there history?
Of them filing an application to the FCC, I'm not sure. I'm not sure what you ended up doing with.
What is
with
that?
Crowley.
What does that mean? This is Bill Nally. What's a companion?
Well,
app?
the companion is that's the one that Globalstar files.
Right.
The license application is what you file. Ours is just a
Right.
complementary.
We submit everything through the NTIA, and Globalstar and Iridium are filing things to the FCC. Is that what he's talking about companion?
No, what I'm saying is that the your request, you need to request from the FCC authorization to use that spectrum in space.
Right, and we're doing that through notifying Murbach. That's what I was asking Marcus. As we've instructed Marcus and another project, they go back and they're coordinating with Globalstar Iridium to send the proper documentation to the FCC to utilize their systems.
Right.
Mark, did you do any other filing of paperwork, or was that entirely upon Globalstar and Iridium when you did before?
Well, we can only, Globalstar and Iridium, I can't speak for Iridium. Globalstar, the only application we can do is to be able to receive your signal and handle that service. But there's something missing there, which is that there's no authorization of use of that band for your bird to transmit and in space. And that's the part that has to be submitted by the mission office or by the NTIA or by someone to the FCC. And the way I read the 7.23, it's something that the mission is responsible for.
Yeah. And I was curious about it because the instructions, and we haven't done the Globalstar yet, we've done Iridium, is we have not had to file anything through the NTIA for the usage of the spectrum. We've noted it to the NTIA in what's called system review submissions. But again, like I had mentioned with Marcus, and he could speak to at least the Iridium, they worked with Iridium to file to the NTIA of the intent to utilize it, and then NTIA would do the rest of the whatever, if there was frequency filing or other notifications. So I'm actually in a gray area here. I'm asking the questions, is that true, Marcus, or are we seeing something different with Globalstar than we are with Iridium, or maybe there's something coming down with the FCC where we have to change our processes, where we have to, the missions have to do some additional filing other than just spectrum licenses through the NTIA?
I think ours is, perhaps you can correct me, but I think it's been consistent with your guys' experience. We have our matrix of frequencies that we filed to the NTIA, no hybrids, no, okay, so, and we have a great example of this right now. We have a SRI experiment. It's part of our matrix. We submit that to the NTIA, get that file number to Iridium, and then they just file to the FCC asking permission for their L band. Mm-hmm. That's the process as we understand it. Correct, Bill? That's all we've done. And we're doing it again twice more.
Yeah. And I'm sorry, I dropped off the line when you went to mute, and I see Mike Miller's comments there, and it's like, what I'm looking at, FCC has said if you're federal, you do not apply to the FCC, and that's true.
Right.
100%, we don't file. What happens behind the scenes with NTIA doing things in coordination, I'm not aware of.
Correct.
But I am looking at Mike's comment here.
Yeah, so the ITU is, in Attila, for example, this is his area, but the ITU is very concerned about the fact that there are satellites going up that may have received some national authorizations, but that were not coordinated through the ITU. So the ITU, which is, has the allocation for the worldwide, it says, the various countries are going and just saying, well, we authorized it, so it should be good with the rest of the world, and they want that to be coordinated through there, and that's that presents a risk to a serious risk to future successful use of this, because the more you ignore them, it just doesn't go well, and so that's the issue. So our approach is to let's make sure that we give the FCC everything they need to coordinate. If they coordinate or if they don't, that's something else. But we had to look at the issue of the products themselves. Your implementation doesn't need an FCC approval if you're only covered under the NTIA. But to operate on our system, you need to demonstrate that it's compliant with the FCC emissions restrictions, because that's what our system requirements are, and that's also what our requirements are for the for the worldwide allocation. And so that's why it is. So I think that there's something being missed there, and it's becoming a very hot topic.
Can you hear me?
That's you, Mike?
This is Mike Miller. Can you?
Go ahead and try to get your question in.
Okay, thank you. Joe, what you're saying makes complete sense. And it has been something that up till now, that to me, and Bill Notley, correct me if I'm wrong, the NTIA process does not notify or coordinate or file with the ITU. In the United States, the only conduit to the ITU is the FCC, as you've indicated. So this will be a new path to tread, in my experience anyway, where we have something that's designated a federal mission, that we're working through NTIA, and yet we need to notify ITU. And the way to do that is to knock on the door at FCC, and so far we have not asked for this sort of service. And I appreciate what you're saying, that this is not exactly getting a license, this is getting ITU coordination. And that may be a new service package that will require some development with FCC, unless you have prior experience of payloads doing this. And that was my original question.
Yeah.
Are you aware of others who are federal missions who've handled it this way?
Bruce, this is Charles. I think we're getting a little bit off the nominal schedule.
Yes, we are. I was
both in
just going to
time and content. Yeah. I know I have a meeting I must attend over the lunch break. I wanted to maximize my participation here. I'm really hoping we could get on to the topics of some of the future needs that we may see based on the missions we have coming up. Really